Happy Monday, everybody. What's going on? So this is the end of the first week, and hopefully most of you had a chance to do the homework questions. Just sort of as a caveat to everybody, this isn't about grades. The, o- the only grade that you need is if do you get hired or not? Do people appreciate your code or not? Okay, and the homework questions were really meant to show you the type of things that they're literally going to ask you on a interview, and the things that they're going to expect you to sort of know if you want to have any responsibility. So I really encourage you to keep revisiting these and memorize these and really get as deep as possible as you can with each one of these, in terms of just being able to explain it. Because if you can explain it, you're already gonna, even if you don't fully understand design patterns or algorithms or big Indian or little Indian or O notation or any of those technical things, trees and graphs, and you know you'll still be able to talk about it. So let's just go ahead and get started. Okay, so the first question is, what is a software engineer? What do they do? Keeping it as short and concise as possible, but trying to encompass as many things as possible. A software engineer is a person that solves problems with computer code or technology, if you just take away the software. Software engineers solve problems. Okay, they don't just write code, but they look at the problem and they find the best way to solve it. Okay, so that's what you're trying to do when you're becoming a coder. Everyone's trying to just get a job. They're attracted to the six figures, but trust me, you're going to be sitting there for 8, 10, 12 hours a day in front of a computer that's going to weed out those who really want it and who don't. And if you really want that, if you want to be able to enjoy your job, enjoy the challenge and it not break you down, and you had the money, ball it out, you're going to have to understand that you're solving problems. So the faster that you understand that, and so the key is understanding the problem you're trying to solve. Okay, that's what they do. They understand the problems that they're trying to solve and apply readable code that can be extended to it. They're not just hacking things together just to get it to work. That's a prototype. Software engineers create works of art. If you look at the Colosseum, you look at the pyramids, they're still standing. They didn't just throw that together. Software engineers put all the pieces together so that they don't fall apart. Okay? So I don't need to go too much deeper into that, but it's not just being a coder. And actually, in the industry, just being a programmer, that's a derivative sort of title. That's not really a good title. You want to call yourself a software engineer as soon as possible. Okay? So how do you become a software engineer? Solve problems with technology. You solve problems with code. Get better and better at solving problems. It isn't just solving, code problems that you find on, Code Academy, all that. That's great. But you want to go out in the real world and solve real problems for real people. And the more you do that, you're going to get better at that. You're going to really prove your weight. So you become a software engineer by constantly solving problems with code. You don't have to go to MIT. You don't have to go to Berkeley or Stanford or work for Google or YouTube or know a million languages or have a PhD. I mean, all that stuff is great. But at the end of the day, Elon Musk taught himself rocket science, right? And look where he's at. You got to work hard. You got to practice, and you got to work at solving problems. So that's sort of and taking even a further step back, that's my whole goal with this boot camp, okay? It's not just to make you a Python or JavaScript or a server admin or Scrum or anything. It's to get you to understand all the tools in your disposal, all those tools in your arsenal to solve problems. And you go out there and solve problems. Because it's not just about making the money. I know that we're all trying to work hard and make money, but if you look at the bigger picture and you're like, look, I can really make a difference in this world with software, you're going to get to that 6 figures faster, okay? So that's that. What are the parts of a web application? Okay. What are the parts of a web application? A server, right? A server, a computer. This all starts with computers. We won't get into the details of the parts of a computer yet, but you know it's a computer. The computer has to have some type of internet attached to it, right? And some type of static IP, so that way the DNS is able to resolve that IP address to some type of domain name and actually access your computer. You're going to need some type of software on there to receive those requests and serve up the page. That's the server software on the computer, such as Apache that we've already installed. Okay. You're going to need some type of language, some type of computer software, programming language in order to process that request. So it's not just the server, but the server takes that, and then you take that request and then you have to decide what to do. The server doesn't really know unless it's just serve me this file, and even then you have to point to what the file is and what type of files you're allowed to serve and this and that. So you need a computer, you need internet connection on that computer, you need a static IP address, you're going to need some type of software to serve those requests. Node.js can do that. You're going to need some type of programming language to then take those requests and process them and spit out some output. And you need some type of language to output it, right? That's HTML, it's CSS, it's partly JavaScript. JavaScript can also process, but in the browser, mainly when you're dealing with jQuery, you are sending and receiving requests via AJAX, but you're mainly adjusting the view. And finally, you need somewhere to store the data, so that way the software remembers, the application remembers what happened last. You got to remember that HTTP requests, which we're going next, are stateless. They don't remember what happened, okay? So we need some type of technology to store the end of the processing, the output, so that we can come back for it later, and then we can build on top of it. So what are the parts of technologies used in a web application? A computer, a constant internet connection, static IP address, some server software like Apache to intercept those requests. That's 4 things. 5, you need a programming language to process the requests coming from the server software like Apache. You're going to need some type of outputting language to show the results. You're going to need some type of language to store it, some type of system to store it. So that's a web application. Okay. What is HTTP? Hypertext Transfer Protocol. Let's go. Let's go ahead and Wikipedia this up. Okay. Is an application protocol for distributive, collaborative, hypermedia information system. Hypermedia. Hyper meaning linked media. Hyperlinks. HTTP is the standard of the web that we use. They're GET requests. They're posts. They're stateless. Okay. They're built on top of a TCP connection. So we could get into all the different layers, and we'll do that separately because it can get confusing. But HTTP are basically basically stateless methods that allow two computers to sort of communicate with each other. Okay, and remember they're stateless. So once it's sent, the sender and the receiver doesn't remember it unless you store that. Okay, and there's different methods. There's a get, there's a head, there's a post, put, delete. You know, some of these are a little bit more obscure, and we're gonna use these in, you know, for real. We're gonna use these in a project. And you're not going to really be able to articulate the deeper stuff and really understand it until we start using it. So those of you that sort of understand that, great. If not, we're going to come back to TCP connections and all the different layers that are involved, which gets really technical. But if you understand that stuff, trust me, you won't have to be the best coder, but you'll be able to get a job because they're going to ask you this stuff. And if you can explain it in an articulated way, because they're going to grill you, you're going to be good. So we're going to come back to the nuts and bolts, but HTTP is really the way that servers are communicating with each other. The main way that we use internet. Requests and response. How the browser talks to the server and the server talks back to the browser. Okay? Well, we're gonna come back to these because it gets a little deep. How do you improve at programming? Practice, practice, practice. Okay? And every time you practice, try to incorporate something new. You got to feel a little uncomfortable every time and then practice it. Learn design patterns. Learn systems thinking. Learn how to think through the flow of the programming before you start typing it, so it's in your head. It's all that kind of stuff. It's the stuff that we already sort of know, but specifically learn design patterns, learn systems thinking, and obviously just practice programming. Because the more you know how these parts work together, it's going to become second nature. What is HTML? Let's type it in. So HTML is a markup language, okay? It's not really a programming language in the sense that it's going to take something and then process it. It's a language that's used for presenting data. And it's also a way to show links, so that way users can get to different sections of the page or on the website or to other websites. And there's all types of HTML elements, right? But they're really just these tags that surround text that it's annotations. It's a language used for displaying. Okay? This Mozilla Developer Network is great, so you're really going to have to hit it up. What is CSS? Cascading style sheets. Okay? It's used to enhance the visual display of the HTML. Okay? It's cascading because you can add styles on top of each other and they sort of cascade. They, go out to all the other elements that are embedded in them. If you put a div inside a div, the parent div styles are going to apply to the child's div unless you override them in the child. Okay, it's how you get everything to look like this. If I go in here, let's see if I can redo this. Go to sources, I believe, CSS. Let's look for we are looking for the CSS. Scripts. They're gonna make me look for it. See what just happened? This is the HTML, this is the CSS, it's all minified. So all the spaces are taken out and it's put together. When you do that and you minify code, it makes it smaller in byte size, so it takes up less room on the server and it takes up less room on the line. So when you send it across, it's going to take less time, less bandwidth. So you see that? You saw the page we just saw? This is just the raw HTML. of the Mozilla Developer Network. You see how this is all HTML is, okay? That's HTML. So you can read words. This is like web negative 0.0, right? I refresh it so we can see the CSS reapplied. You see? CSS is what changed it from that drab document to what we see there. So that's how they fit together. It's two things, HTML and then the CSS, okay? JavaScript. So JavaScript is a programming language. Up until recently, it was mainly a programming language that was inside of the browser. Okay, so that means that you could do your processing, but only within the browser. And the browsers all were standardized in such a way where JavaScript can't go out into your files and start doing crazy things. Unless obviously it found some bug or some other exploit. But now, thanks to Node.js, you can actually program with JavaScript as if it were Python or PHP or Java, in the sense that it can live on the server and directly intercept requests from the server software like Apache. So what does that give you? That just gives you, if you're really good with JavaScript, you're used to that syntax, you'll be able to work with it. You know, switching from Python to PHP to Java to JavaScript, they're slightly different because of the way you write them is different. They have different conventions. So if you're just using the JavaScript convention, that might be Node.js might be something that you want to look at. My personal opinion, I think that you should start with the classic server-side languages first. PHP, Python, Java. Get those down. Learn how to use JavaScript in the browser. And then go to Node.js. I know Node.js is, a lot of people might be saying they're hiring for it, and I'm not saying not to learn it, but I think that it puts you into more of a corner. Whereas if you learn these more traditional ones, you'll be able to do anything. But if you learn if you only know React and Angular or Node.js, you're not going to easily be able to go to Java or Python. But if you know Python and Java and PHP and C and all that stuff, don't worry about Node.js. It's going to be easy, okay? So JavaScript is a programming language mainly used in the browser, okay? And it interacts with HTML elements. It can send and receive requests to the browser via AJAX. So it'll send it will send text from the web page to the browser, such as information from a form, to a server. The server-side language like Python or a framework like Django built on top of Python will intercept the request from JavaScript from the browser. Let's say you're submitting a form, it will do all the manipulations, insert into the database, maybe do validations, spit back a response to the JavaScript, the AJAX, asynchronous requests, and then the JavaScript can then manipulate it and present it in the browser. And things such as jQuery basically take JavaScript, and it basically creates very helper functions, because with JavaScript, especially for the longest time, all the browsers implemented JavaScript differently. So most of these browsers are built with like C, C++, some type of compiled language, right? And that compiled language will have a JavaScript engine inside of it. I think Chrome uses V8. I think Firefox has used SpiderMonkey. I'm going to look into that. But these are, again, software programs. I think actually Mozilla might be written in Rust. But regardless, they're written in some other lower level language. Most of the software that's on your computer, that's on the server, that is in a web app, is going to be built with some type of compiled language like C that's very quick and efficient. And the JavaScript compilers are no different. And they follow the ECMAScript you see here, which is just the rules for how they believe JavaScript should be implemented. And there's so much leeway in between all the different things that they say, that each browser can sort of implement it differently. And because of that, you might have to program the same thing 2 or 3 times to account for different browsers. So, if you want to animate something and you want to do it in pure JavaScript, you might have to program it for Chrome and Firefox, and you find that it breaks on Internet Explorer, so you got to do something else to make it work. Whereas jQuery sort of went through all those and then gave you one simple function, and it will take care of all the browser quirks. And because of the number of people that have been using jQuery, it is, you can consider it almost like JavaScript. And in fact, it was so influential that you're seeing now inside of the newer versions of ECMAScript, of JavaScript, things from jQuery. So it was really instrumental in making JavaScript catch up with the times and become more user-friendly. So that's JavaScript, okay? We're gonna come back to more of these things. So what is Linux? Linux is an open source operating system. And like ECMAScript, it's like a specification in terms of how they think the operating system should work, and then there's different basically flavors that implement Linux. And there's, Linux has a long history. You should go read about it, because that's another one of those things you got to know as a software programmer. And I think his name's Linus Torvald, right? Linus Torvalds. This man's a G. He's a gangsta. You should read about it. But back in the day, in the 60s, you see 1969, 1971, the first operating system, Unix, was proprietary. Okay, so that, just like Windows, you had to buy it if you wanted to use it. Okay, and Linus came along and basically created a free version of Unix. So all your other programs and softwares that you built on top of this proprietary software, he came around and created an open source, a free version of it. So all your other software could sort of work, and you could use this free operating system. Okay? And most of the web runs on Linux. You got huge corporations that might be using some IBM's OS or some proprietary thing for some very narrow applications. You got plenty of people using Windows Server. You got plenty of people using, the Mac server, which PS is built on top of a Unix-like shell, a Linux similar type shell. So we are using a version of Linux called Red Hat. So there's all these different kinds of Linux, but Linux is an open source operating system. If you get a laptop, you get a computer, you need some type of software to manage the everything, the power, the keyboard input, the mouse input, the screen, everything. It's not a mechanical engine where all the pieces just work. Each piece has a potential. The battery, the CPU, the RAM, all that stuff has potential, and the embedded software boots it up, and the old operating system handles all that stuff. So that way, when you're creating a new folder or a new file, you don't overwrite some other critical file. There's a lot going on. And for this man to come along and create a free version of it, he's the reason why we're still able to do anything that we're able to do. Because trust me, all these big corporations, all they want to do is close it down, take your money, right? So you got to know that if you're becoming a software developer, you're becoming a quote-unquote programmer, this is what we do. We're trying to open the web. The web is for all of us. It's the power for all of us, right? And I'm getting a little bit on my political high horse, but this guy he wasn't about money, and trust me, it wasn't easy what he did. So really sit and read this, okay? And the version of Linux we are using is Red Hat, Okay, and what's good about that is a lot of big companies use Red Hat. Okay, and so if you know that, you're going to be able to command line, and you're able to edit permissions. So let's take a step back. How Linux operates on an old school way of sort of how computers used to run. Back in the day, you know, computers were not small, they were huge, right? They would take up whole rooms. So you couldn't walk around with them like we do with our smartphones or our laptops. But what you could do is create smaller terminals that didn't have processing power, but remote, basically you were able to log into the bigger computer, to the bigger mainframe. And you would do that through a shell, through a command line interface like this. And you would log in and do your thing. So the mainframe would have to have a way of saying this user has access to these resources, this user can do this thing, here's where his home folder is, all that stuff. So you're going to be dealing with user permissions, and it's the same thing. When you log out of your computer, or you create different users in Windows, and you can log in different ones. It's the same thing, but you just do it via a command line. You can monitor the resources of the computer. You do all the things that you would think you would do with Windows. You just do it in a slightly different way. There's different conventions. And because the command line can be used programmatically, you can do very powerful things. Let's say you have 100,000 images that you need to resize and change to a different format. You can very easily do that through the command line. Now, I'm not saying you can't do that through, the DOS prompt back in the day and, other Windows conventions, which we might get into. But because Windows is a closed source environment, it's a closed environment, you have to learn everything their way, and you can't really apply it anywhere else. We're gonna circle back around to those Windows things, okay? So really get your head around Linux. Okay, what is CentOS? CentOS, it's a version of Linux. It's basically the generic version of Red Hat. So if you know how to use Red Hat, you'll be able to use CentOS. And like a lot of these different versions of Linux, there's Mint Linux, there's so many. They do things slightly differently, and some software that's available on some isn't available on others. So that's where it starts getting a little hairy, where you got to know what version of Linux you're using, what's installed on it, all that stuff. Okay, and as a note, we're not using CentOS, we're using Red Hat. That was my mistake. I thought that Amazon Web Services had CentOS, but they don't. But it's actually Red Hat, in my opinion, is better, so that's cool. Scrum. What is Scrum? Scrum is simple. It is the opposite of a big collection of interwoven mandatory components. Scrum is not a methodology. Scrum implements the scientific method of empiricism. They're really getting on their high horse. They don't want to. They're trying to sell you. I want it a little more concise, huh? They're right. So Scrum is a way for companies, organizations, people to plan their work and work their plan, okay? You sit down, you say, where are we at? Where do we want to be? Where's the point A? Where's point B? What are all the things we need in order to get to point B? You break it down in small chunks as possible. How long will it take to get each of those chunks done? And then you meet on very consistent intervals, quickly every day for a quick stand-up to say where you're at, every week to go in deeper to see what needs to be changed in terms of the scheduling, or if there's any issues, or if everything's going right. This is different than the waterfall method, which is what manufacturing and everyone had been using for the longest time, in the sense where you do one thing, then you do the next thing, then you do the next thing, then you do the next thing. Whereas in Scrum, we're looking at everything that needs to be done, and the major parts are moving in parallel. So it's very important that you have team members broken up to do different jobs, and they're all working on different tasks, but they're always checking in with each other to make sure that each part is doing what they're supposed to be doing. And so that's the key why I'm doing this teams, and you should be stoked about it, because when you get a job, you're not going to just go in a corner and program. That's a lie. Don't believe what the TV tells you. They're going to put you in a freaking open office where everyone's going to see you. You're going to have people coming up to you every second. You're going to have to talk. You're going to have to put on a smile. You're going to have that personality. You're going to have to be able to accurately define what it is that you need to get done and how long it's going to take. You're going to have to be able to say very quickly, oh, this is taking me a little bit longer. It's a very active process. So the quicker you're able to reach out with other programmers and work together and even make just a simple web app, but you're able to define jobs, come together, commit it to Git, and have something that works and push it out to the world, you're going to get hired, okay? And I feel a lot of these coding boot camps aren't making it like when you go to get a job, because when you get a job, it's going to be different than school. It's not, we're not sitting around studying design patterns at work, right? You know that. You can sit and look, and it's cool. Some jobs have hackathons, and they do that kind of stuff. That's great. Google's your friend. Hard work's your friend. Working with other programmers outside of work is your friend, okay? So Scrum is being able to work in a group on multiple processes at once, constantly checking in, and by doing this, you're able to better estimate how long it takes to build a piece of software, because companies, that's the hardest thing, is how you do accurately say how long it's going to take for this software, for this video game to be done. Always delays. Things always go wrong. But if you use some type of methodology, you're going to be you're going to be on your way. What is Agile? Scrum is a form of Agile. Let's see if we can find something. Wikipedia, you never let us down, huh? Describes a set of principles for software development under which requirements and solutions evolve through the collaborative effort of self-organizing cross-functional teams. Okay, and that's what Scrum is. But Scrum specifically breaks it down, everything into individual tasks, and then you estimate how long each one of those tasks is going to take. Agile operates on these 12 things. So customer satisfaction by early continuous delivery of valuable software. Welcome changing requirements even in late development. Working software is delivered frequently. Close daily cooperation between business people and developers. Projects are built around motivated individuals who should be trusted. Face-to-face conversation is the best form of communication. Working software is the principal measure of progress. Sustainable development, able to maintain a constant pace. Continuous attention to technical excellence and good design. Simplicity, the art of maximizing the amount of work not done, is essential. Best architectures, requirements, and designs emerge from self-organizing teams. Regularly, the team reflects on how to become more effective and adjusts accordingly, okay? So keep coming back to these things and try to get those in your head, because anywhere you work is going to be using some type of Agile method, more than likely Scrum. Okay, QA, quality assurance, checking your work. That's it. And trust me, that's so hard, because think about it. You spend hours and hours getting it right, and you tested it real quick. Great, it's fine. You push it, I'm done. No, you're not. You have to go through A to Z. You got to click around. You got to resize the browser. You got to put in a whole bunch of crazy characters into forms. You got to try to put some JavaScript that's going to break your form into the form. Quality assurance is trying to break your work and ensuring that your work is solid and it stands up, okay? And so that's why right now we're focused on just homework questions. But when we start really working on these tasks, I mean, the QA, the code reviews, that's where your guys are going to have to show that you're good. If you can, it doesn't matter how, trust me, when you're programming, your manager's not going to worry necessarily how fast you program if you're releasing a program that's as close to bug-free as possible. If you're opening it up in Chrome and Firefox and Internet Explorer and forget it, you're even using an IE8 and IE7 and you're trying to make your software work in as many situations, and especially very harsh negative situations, under load stress, under a database that's getting thousands of requests, millions of requests. Your server's getting so many, it's spun up, it's got 100 requests running in parallel. I mean, these are the things you want to be able to QA. But just at the simplest level, it's checking your work and being confident that your work is going to hold up under, under a typical environment, okay? It's not just coding, running it once, going through the most obvious flow and saying, oh, it works, okay? That's huge. Huge, 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 okay? Python. Let's see if... Google's always your friend. Wikipedia. Now, Python, it's a high-level programming language, higher level than something like C or assembly language. So it's a programming language, okay? It's a dynamic programming language, or scripting programming language, which means you don't have to program it, compile it, and then run it. You can program it and then run it. And there's positives to that. It means quick feedback cycle. You can program and then run it really quick and see what happened. The downside is many of these these dynamic languages aren't as efficient as a C, as an assembly language, as a C++, as a Java. And that's because it handles the memory management for you. Whereas it might be very loose with the types, dynamic types. So that means you can just assign any old thing to a variable. Whereas in something like C or Java, you can give a variable name like X or, whatever, variable name. But you got to state in front of that variable name what it's going to go in there. Is it an integer? Is it a character? Is it an array? And what that does is it allows the compiler to already know that if there's a line of code where you said integer variable X equals, equals the word foo, it's going to say, hey, it's going to throw a compiler error. That's not a number. Wait a minute. According to this variable that you said right here is going to be an integer, but this is a character array. This is a string, depending on what you're using. Error. I'm not going to compile. That's annoying, right? So that's the thing with the compiled languages. It's just like, it might, the bigger that they are, you got millions of lines of code. Sometimes it might take 15 minutes, an hour, overnight to compile, and then you come back and it throws a compiler error or something. That's the negative of that. But the positive of that is that it's basically doing a lot of error checking for you already. So once it compiles, you already have a significant set of bugs that are just taken off the table. Bugs that you're going to see in Python and PHP and Java because it's dynamic, and the software isn't going to know up until the moment that it processes it, and whatever is in there, and this creates very hard to track down bugs. Okay. Another thing about it is, memory management. So you don't have to remember in something like Python or JavaScript or PHP. If you create a variable, put something in it, you don't have to remember to say release that memory so that way something else can use it. The engine sort of handles that for you. Whereas in something like C, you have to allocate the memory for it, and you have to remember to deallocate the memory, or else you create something like memory leak. So if there's a function that you allocated a variable, you did whatever you need to do with the variable, but you didn't unset it through the life of the program, that little bit of memory is unavailable to anyone. That's what a memory leak is. And the more memory leaks you have, and as your software runs more and more, it's just taking up space, and you can create things where if you don't have any more space left on the computer, the memory leaks can eat into important files. So that's another thing with these lower level languages, these compiled languages. They're powerful, C, and they'll wreak havoc on your system if you're not really careful of what you're doing. But that's fine. We're cool. That's why we set up our development environments. We don't put our social security, our baby pictures, important things on computers that we're doing work on. Okay, so we do constant backups, and we use version control, so we ain't worried about that. Okay, and we're gonna get to those kind of things, but we're gonna focus on Python, which is a dynamic type scripting language, and particularly, as it says here, that they're focused on code readability. So there's like a lot of white spaces and indentation, whereas other languages aren't worried about the white space. It's worried about where the semicolon is. So that's what the infamous joke is, I missed a semicolon, because that's the only way the computer is going to know that the end of this line and the start of the next line. Okay, and so Python is the server-side language that would intercept requests from your software like Apache, your server software, and would manipulate, and then you can use it to communicate with a database or communicate with other programs or files that are on the computer, on the actual computer running the server software. Okay. Django is a web framework that's built on top of Python. So it's Python, but similar to like how jQuery simplified things so the way you just need one function call and it handles a lot of things for you. Django sort of does that for building web framework, for building a web application. So it handles things. It makes it easy for you to specify. If you have www.getexperience.co, you can say, all right, /intro will go to this action, and this action will do this, these things, and spit out this view. So Django is built on the model view controller design pattern, and that's essentially a model is some type of thing that you're going to store, some type of entity that has different inputs on it. It's basically a row in your database. Okay, each one of those columns in the database represents a different variable on your entity object. Okay, the controller is basically what intercepts web requests, translates them to understand, okay, if you wanted to go to, getexperience.co/intro, it grabs that and it says, okay, I see that this view is connected, or that URL goes to this particular function, okay? And inside that function, you do any type of setup you need, and then you say render this HTML page. But it's a special HTML page that Django will be able to read, because there's special Python or Django variables that will be embedded in this special HTML, which then gets parsed through the Python and turned into real HTML. So if you have a variable in there and you want to say, if you're creating a welcome screen for a user that just signed in, and right above at the top it says welcome, and then it would be some type of variable. You don't hard code if you have a million users. If you go to Facebook, your username is just a variable. They didn't hard code
there are billions of users, right? That's in a database. It just knows that once you've logged in, it's got a variable that gets set by the that gets pulled into the model, right? And in the controller creates a variable and puts that name, and then in your HTML view or your HTML like view, it spits it out and then renders it into pure HTML, which gets sent over the wire that your browser is able to show you. Okay, so your browser's never touching Python. Your browser, your JavaScript, CSS never touches Python. That stays on the server. Python merely translates whatever processing you need into HTML and then gets sent to you. Okay, and the larger question of what are web frameworks for, they make it easier for you to organize your code, so you're not doing you don't have across all these different files, all these different SQL queries that you did raw that are just select star this, that, and all these different variables and these different hacky ways of intercepting requests to make sure that they go to that this URL goes to this functionality. It organizes it for you, so it makes it easy as the project gets bigger, that you can easily find the file, the line of code that you're looking for, and make changes. It simplifies a lot of things, so that way you can, instead of writing 20, 30, 50, 100,000 lines of code, you can call 1, 5, 10 lines of code, and we'll handle it all for you. And so you might look at these simple Hello World apps with Django, and they're a little bit of code, but there's so much going on behind the scenes. And so in that respect, they're a little bit of a crutch because they're hiding a lot of what's happening, and you're not getting. Eventually, once you become proficient with these frameworks, you're going to want to know sort of what it's taken care of for you, and sort of know how you would do it from scratch if you had to. Because that means when the new framework comes out, or the new methodology that we haven't even thought of comes out, you're going to be ready, because everything builds on top of everything else. So whatever comes next is going to be in some way related to what came before. And if all you know are, single line functions from some web framework that's doing all this work for you, you aren't really powerful yet. You aren't really a software developer yet. You can make a few web apps, but you got to understand it, okay? But for now, don't worry about that. Right now, we want to understand the framework. That's what makes you a software developer for now, but don't get stuck on there. That's all I'm trying to say. So what is MySQL? It's a database. It's a piece of software that runs on a computer. Doesn't necessarily have to be a server. It doesn't have to be a server. It runs on a computer, and it stores data in a row, column sort of, in an Excel-like manner. And each one of those columns is going to have a certain type, integer, character, or whatever, which the database engine will use that, similar the statically compiled programming languages. It'll know. It just makes it easier for it to retrieve the data and give it back to you. Okay, so MySQL is going to be is an industry standard right now, and it's going to be the database that we're using. So it's just a way of storing data, persisting data, in a web application, so way you can store it and retrieve it later. Okay, you can even do processing in MySQL alone with no Python, no nothing. Those are called stored procedures, and we might get to that later too. What method was used before Agile? What were the downsides? We talked about that. Waterfall. The downsides were because you went from A to B to C to D. You did everything in a row. If the first thing messes, if anything goes wrong in the first thing, that affects everything else behind it with the waterfall method. And so typically, as you get toward the end, you become more and more rushed. And the last thing in the waterfall is always testing, and that always seems to get cut out because timelines are always too short. And testing is the one thing that you really want to be focusing on, because if you got your automatic tests, your unit tests, your manual tests, your browser tests, all that stuff, you want software that works, because software that doesn't work is not going to make you money. It's not going to get you a job. It's not going to keep you in this industry. What is web accessibility? Let's look. In a nutshell, it's browser and HTML conventions that interface with the computer in such a way that allows people that have disabilities to be able to interact with the computer better. So if you use these HTML web accessibility features, then people can use the Siri screen reader and all the stuff that's built in to read, if they're blind, to read the web page to them in the correct order. That allows them to just hit tab and it will go through the form in the right order. And there's a bunch of different things, but they're basically allowing people with disabilities to be able to use your website. And it's important. And there's a lot of different things that you can do. It's a lot of different, there's just different guidelines. But I think just generally it's important to know that, we all aren't, gifted with the same abilities, and we should be thankful for that. And as a software developer, someone who's trying to solve problems for people with technology, with software, those are going to include people with disabilities, especially people with disabilities, right? So web accessibility is important in that respect. Design patterns. They're patterns of design. They're recipes, general ways of doing things to help you out in different programming situations. And they aren't so specific like a recipe where it's like half a tablespoon of salt, 2 cups of water, 2 tablespoons of butter, whatever that is. It will just tell you, you combine water, fat, sugar, flour, and you can create some type of cookie. And that, and the specific cookie that you want to make is going to depend on your situation. So design patterns are basically, ways to solve common problems that software engineers run into. But you don't want to make them too specific because every situation is unique, and they're abstract enough to go to be able to be used in many different situations. And you're going to find many times that you're going to use combinations of patterns, and it's not just so cut and dry where one pattern begins and another one ends. But just like you do those coding problems, those practice problems on a lot of these websites, knowing how to do these design patterns and think of ways to use the design patterns is going to make it easier. So when you are presented with a new problem, you're going to have an intuitive sense of sort of, okay, I'm going to need some type of doubly linked structure, doubly linked list structure that's going to be used in an MVC environment, and I might need a fly weight over here. And there's, how you specifically implement that is going to depend, but you're already able to cut down the problem into smaller bite-sized chunks. GitHub. There are ways to store your code, to back up your code, and it allows other people to work with you on the code. That's really what it's for helping you back up your code. It's simple. GitHub is a site that visually shows you what's in your Git repository. Okay? What is a command line? This. It's a way of interacting with a computer via text. Okay? A shell script is a piece of text that's fed into the command line to control the computer. So shell scripts control computers via the command line. Okay? That's things like cron jobs, So that's how you physically on the server do these things behind the scenes that don't necessarily have to do with someone going to their browser and requesting something on your server. Okay? We talked about jQuery. Angular is very similar to jQuery, except for it makes it even easier. So it makes it a lot easier to create dynamic web pages that need to be updated constantly. With jQuery, there was a lot of code that you would have to do. You'd have to keep track of a lot of different elements. With Angular, it's made it even easier. But the downside of that is that it's abstracted a lot of JavaScript away. Another thing is people just want to learn Angular not understanding that it's built on jQuery. So you're better off just learning jQuery first, and then once you start doing Angular, you're going to be able to do all the little things that you need. Okay, so that's the first video. I'm gonna end this one. The next video, I'm gonna talk about the different jobs and the different tasks. And then in the video after that, I'm going to finish out with showing you some Django, some MySQL on an EC2 instance. Okay? Excellent.